Welcome to Deep Dive. This podcast is brought to you by Liminal Martech. Liminal is the first Portuguese company specialized in strategic consulting and marketing operations. If you want to grow your business and deliver better customer experiences with marketing technologies such as Salesforce, HubSpot, Zoho, go to www.liminal.pt and find out how. All right, get ready to unlock some serious marketing magic, because today we're diving deep into Data Science for Marketing Analytics, second edition. Think of this as your cheat sheet to this data science Bible, extracting the juiciest bits to supercharge your marketing game.
You know what's really cool about this book? It doesn't assume you're a data whiz already.
Oh, that's nice.
It starts right from the basics, even explaining different types of data you might encounter as a marketer.
Okay, let's break that down. We're talking about things like those massive customer databases, right? But what else?
Exactly. Those neatly organized databases are called structured data, but then you've got things like JSON files, which are semi-structured. Think of them like data with a bit more wiggle room. And then there's the wild west of unstructured data, like those Excel spreadsheets we all love and hate.
Ah, spreadsheets, every marketer's best friend and worst nightmare. But regardless of the type of data, it sounds like we need a way to, tame it before we can actually use it, right?
Absolutely. That's where Python and this awesome library called Pandas come in. Imagine Pandas as your data superhero, swooping in to wrangle all that messy data and make it usable for analysis. Python is the language that gives Pandas its superpowers.
So it's like having a data translator that speaks both spreadsheet and insights. But how do we actually get those insights once our data is all cleaned up?
Well, one of the simplest yet most powerful tools is the groupie function in Pandas. Let's say you're running email campaigns across different customer segments. Groupie lets you slice and dice your data to see, for instance, which segments have the highest open rates or click-through rates.
So instead of just seeing overall campaign performance, I can pinpoint which segments are really engaging with my emails. That's gold for targeting future campaigns.
Exactly. It's all about finding those hidden gems in your data. And that brings us to KPIs, your key performance indicators. Whether it's revenue, customer lifetime value, or something else, data science gives us the tools to measure these with laser precision.
This is starting to feel like I'm getting a superpower upgrade. Okay, now let's talk about customer segmentation, which the book seems to really focus on.
You know, it's funny, you can segment all sorts of things like products or offers, but this book zeroes in on segmenting customers.
Okay.
And for a good reason. By grouping customers with similar traits, we can tailor our marketing messages and strategies for maximum impact.
Okay, that makes sense. But how do we actually create those customer segments? Do we just manually sort through mountains of data?
Not necessarily. The book dives into this really cool concept called clustering, which is a type of machine learning. Specifically, we're talking about unsupervised learning, where we let the algorithms do the heavy lifting and discover patterns in our data.
Unsupervised learning. So it's like letting our data loose in a playground and seeing who forms friendship groups.
That's a great way to put it. Imagine plotting your customers as points on a graph, where each point represents a customer and their characteristics, like age, purchase history, or website activity. Clustering algorithms grouped nearby points together based on those characteristics.
So customers who are similar end up in the same cluster, like those playground buddies. Now, the book mentions two specific clustering algorithms, right? K-means and mean shift clustering.
Right. With K-means, you have to tell the algorithm up front how many clusters you want. It's like saying, hey, algorithm, I think there are 3 distinct groups of customers in my data. Go find them.
So you need to have some initial hunch about your customer groups before you even start.
Exactly. But with mean shift clustering, you don't have to specify the number of clusters. It's like saying, hey, algorithm, you're smart. Go figure out the natural groupings in this data.
So it takes some of the guesswork out of the process. Now, how do we decide which characteristics to use for clustering? We wouldn't want to group customers by their favorite color. Right?
Definitely not. Choosing the right criteria, or features, as they're called in data science, is super important. The book highlights that segmenting customers by income and spending score, for example, can be super insightful.
Okay, I can see how that would be useful. Tell me more.
Well, imagine uncovering a group of high-income customers who, surprisingly, are low spenders on your products.
Oh.
That's valuable information. You might target them with premium offers or loyalty programs to encourage more spending. On the other hand, you might find a group of lower-income customers who are high spenders. You could tailor marketing messages to highlight value and affordability for them.
This is blowing my mind. We've gone from messy data to actionable insights about our customers. I'm starting to see how data science can really be a game changer for
It
marketers.
is, and we're just getting started.
I can't wait to see what other gems we uncover.
Welcome back. Last time we talked about how to wrangle your data with Python and pandas and how to uncover hidden gems using the group B function. We even explored the fascinating world of customer segmentation using clustering algorithms.
That's right. We learned about how clustering helps us group similar customers together, sort of like those playground buddies we were talking about. But I'm curious, how do we know if we've created the right number of clusters? Is it just a guessing game?
Not at all. The book actually dives into several methods for choosing the optimal number of customer groups, and they're surprisingly intuitive.
Okay, I'm all ears. Let's start simple. What if we just eyeball our data and see if any natural groupings pop out?
That's actually a great starting point, especially if your data is easy to visualize. Imagine creating a scatter plot where each point represents a customer. If you see a bunch of points huddled together, like a group of penguins on a chilly day, that could indicate a natural segment.
I love that analogy. So we're literally looking for visual patterns in our data to guide our segmentation. But what if our data is more complex and we can't easily visualize it?
Well, then we can turn to more quantitative methods. One common approach is called the elbow method. It involves plotting the sum of squared errors, or SSE, for different numbers of clusters.
Okay, sum of squared errors. That's it sounds a bit intimidating. Can you break that down for me?
Sure, imagine each cluster as a little neighborhood, and the SSE as a measure of how spread out the houses are within each neighborhood. We want to find the number of neighborhoods where the houses are closest together, minimizing the overall spread.
So we're looking for the point where adding more clusters doesn't really improve the tidiness of our segmentation.
Right. Exactly. And often this point shows up as an elbow shape on our plot, hence the name elbow method. It's all about finding that sweet spot where adding more complexity doesn't give us much extra benefit.
That makes sense. But I can't help but feel like visual inspection and even this elbow method are still a bit subjective. Is there a more objective way to measure how well our clusters fit the data?
Absolutely. That's where the silhouette score comes in. Think of it as a happiness score for your data points.
A happiness score. I love that. Tell me more.
Well, the silhouette score measures how similar each data point is to its own cluster compared to other clusters. It's like asking, hey, data point, how comfortable are you in your assigned group? Would you rather hang out with the folks in the other group?
So a high silhouette score means our data points are happily settled in their assigned clusters, feeling a strong sense of belonging. And a low score means they're feeling a bit out of place.
You got it. A high silhouette score gives us confidence that our clusters are well separated and our model is doing a good job of grouping similar customers together.
This silhouette score sounds like a powerful tool. Can we use it to compare different clustering algorithms too? Like, could we see if k-means or mean shift clustering gives us a happier bunch of data points?
Absolutely. You can run both algorithms, calculate the silhouette score for each, and choose the one that performs best. It's like having a standardized test to compare the effectiveness of different segmentation approaches.
That's brilliant. It takes the guesswork out of choosing the right algorithm.
Now, speaking of different approaches, I remember the book mentioned a rather intriguing algorithm called mean shift clustering. What's so special about this one?
Ah, mean shift clustering. It's a bit like having a self-driving car for segmentation. Unlike k-means, where you have to specify the number of clusters beforehand, mean shift figures it out on its own.
So it takes the steering wheel and says, trust me, I got this.
Yeah.
How does it actually work its magic?
Imagine each data point as a little hill. Mean shift starts at the top of each hill and gradually rolls down, following the slope towards areas of higher density. So it's like rolling down a hill until you reach a valley where most of the data points are congregating, forming natural clusters.
That's a great way to think about it. It's a very intuitive approach, but it does have its limitations. It can be a bit computationally expensive for large data sets, and it might not handle high-dimensional data very well.
So it's like having a powerful truck, great for certain terrains, but not ideal for navigating narrow city streets. I guess it's all about choosing the right tool for the job. Are there any other clustering techniques mentioned in the book?
There are. The book briefly touches upon K-modes clustering, which is specifically designed for categorical data.
Right.
For instance, if you want to segment customers based on their purchase history, which consists of categories like product types rather than numerical values, K-modes would be your go-to.
So we have a specialized tool for dealing with categories. What about situations where we have a mix of both numerical and categorical data, like customer demographics and purchase history combined?
No problem. The book also introduces K-prototypes clustering, a hybrid approach that can handle both types of data simultaneously. It's like having a Swiss Army knife for segmentation, ready to tackle any data challenge.
I love how there's a tool for every situation. But with all these sophisticated techniques, I'm wondering, do we ever need to step back from the numbers and consider the bigger picture?
Absolutely. Statistical measures like the silhouette score are incredibly valuable, but they shouldn't be the sole deciding factor. We always need to put on our marketing hats and ask, do these clusters represent meaningful customer segments? Can we tailor our strategies to these groups effectively?
So we're not just chasing the highest score, we're making sure our segmentation actually makes sense from a business perspective.
Exactly. Imagine creating a segment of customers who are all over 80 and have no internet access. It might be a statistically sound cluster, but from a marketing standpoint, it's probably not very useful.
That's a great point. It's all about striking that balance between data-driven insights and our understanding of the market and our customers. Now, before we move on, I'm curious about this train and test split that the book mentions. What's that all about?
Ah, that's a crucial concept. It's like having a test kitchen for our segmentation. We hold back a portion of our data and use it to see how well our model performs on new, unseen data.
So it's like a dress rehearsal for our segmentation, making sure it can handle the spotlight of real-world data.
Exactly. If our model performs well on both the training data and the test data, we can be more confident that our segmentation is robust and reliable, ready to guide our marketing decisions with precision.
That's a great way to put it.
Hmm.
Now, so far we've been talking about unsupervised learning, where the algorithms discover patterns on their own. But the world of data science has even more tricks up its sleeve, right?
You're right. The book also delves into supervised learning, where we use labeled data to train our models. Instead of just grouping customers, we can actually start predicting their behavior.
Predicting behavior. That sounds fascinating. Tell me more.
Well, imagine being able to predict which customers are most likely to churn or which products they're likely to buy next. That's the power of supervised learning. We'll dive deeper into that in the next part of our deep dive.
All right, we're back for the final part of our deep dive into Data Science for Marketing Analytics, second edition. So far, we've learned how to wrangle our data, segment our customers, and even evaluate the happiness of our data points. But now, things are about to get really interesting as we step into the realm of supervised learning.
You're telling me. With supervised learning, we're not just grouping customers anymore, we're predicting their behavior. Imagine being able to forecast which customers are most likely to churn or what products they're likely to buy next. That's the kind of power that data science can put in your hands.
Okay, that sounds incredible. But I have to admit, supervised learning still sounds a bit mysterious to me. Can you demystify it a bit?
Of course. It's all about learning from labeled data, where we already know the outcome we're interested in. Let's take churn prediction as an example. Imagine you have historical data on your customers, and you know which ones churned and which ones stayed loyal.
So it's like having a cheat sheet from the past to help us predict the future.
Exactly. We feed this labeled data to our model, and it learns the patterns and relationships that distinguish churners from non-churners. Then, when we give it new data on a customer, it can predict how likely they are to churn based on those learned patterns.
That makes sense. But we already talked about linear regression for prediction. How is this different?
You're right, linear regression is great for predicting continuous values like revenue, but for predicting categorical outcomes, like whether a customer will churn or not, we need a different tool, and that's where logistic regression comes in.
Logistic regression. Okay, that's a new one for me. What's so special about it?
Well, unlike linear regression, which gives you a continuous value, logistic regression spits out a probability score. So instead of just telling you, yes, this customer will churn, or no, this customer won't churn, it gives you a more nuanced answer like, this customer has a 75% chance of churning.
So it's like having a risk assessment for each customer. That's super helpful for prioritizing our retention efforts.
Precisely. You can focus your energy on those customers who are most at risk instead of spreading yourself thin across the entire customer base.
This is starting to feel like we're getting our marketing crystal ball, powered by data instead of magic. But I'm curious, how do we actually go about building this churn prediction model? Is there a specific process outlined in the book?
Absolutely. The book walks us through a very practical framework called the HCMM pipeline. It stands for Obtain, Scrub, Explore, Model, and Interpret.
A BMMN. That's a mouthful, but it sounds catchy. Can you break it down for us?
Sure. Obtain simply means collecting the data we need from all our sources. Scrub is all about cleaning and preparing our data, making sure it's consistent and ready for analysis. Explore is where we really dive deep into the data, using visualizations and statistical summaries to uncover patterns and insights. Model is where we choose our algorithm, like logistic regression, and train it on our data. And finally, interpret is about making sense of our model's results and drawing actionable conclusions.
So it's a step-by-step recipe for turning raw data into marketing gold. The book uses a real-world example to illustrate this process.
Yes. It walks us through a case study of a telecom company that wants to predict customer churn. They gather data on customer demographics, usage patterns, billing information, you name it.
It's like building a comprehensive profile for each customer,
Yeah.
trying to understand what makes them pick and what might drive them away.
Precisely. And the book really emphasizes the importance of that explore phase where you use data visualization tools and statistical techniques to uncover hidden patterns and correlations.
So it's not just about blindly feeding data into a black box.
Mm,
We need to roll up our sleeves, get our hands dirty, and really understand our data before we can build a meaningful model.
exactly. And once we have our model built, we need to evaluate its performance. The book introduces several metrics like accuracy, precision, and recall that help us assess how well our model is doing.
So it's like grading our model's homework to make sure it's actually learning something useful. What if it's not getting a passing grade? Can we improve it?
Of course. The book dives into techniques like feature engineering and hyperparameter tuning to boost our model's performance. Feature engineering is like adding secret ingredients to our recipe. We can create new variables from our existing data that might be more predictive of churn.
And hyperparameter tuning, that sounds a bit more technical.
It's all about fine-tuning our model, like adjusting the oven temperature or baking time to get the perfect cake. We can tweak the settings of our algorithm to optimize its performance.
So building a churn prediction model is an iterative process, constantly refining and improving our approach until we get the best possible results. What other insights from the book stood out to you?
The book really drives home the point that data science is a powerful tool, but it's not a silver bullet. Our models are only as good as the data we feed them, and we need to be aware of potential biases. It's important to continuously monitor and evaluate our models, especially as the world around us changes.
That's a great point. We need to make sure our models are staying relevant and providing accurate insights as new data comes in and customer behavior evolves. Well, we've covered a lot of ground in this deep dive into data science for marketing analytics, second edition. What a journey.
It certainly has. This book offers a fantastic roadmap for marketers who want to leverage data science to gain a competitive edge. From prepping data to building predictive models, it's packed with practical techniques and real-world examples that can really empower marketers to make smarter decisions.
I couldn't agree more. If you're a marketer looking to unlock the power of data, this book is a must-read. It's your guide to navigating the exciting world of data science and driving business growth in today's data-driven world. And remember, Liminal MarTech can help you implement these techniques, driving business growth and improving customer experiences. Go to www.liminal.pt if you want to know how to grow your business with MarTech.